let's take a marketing agency as an example. The onboarding workflow I described applies to almost every business that has customers. But for a marketing agency, right after that onboarding, the AI may generate the client briefs, and the AI may generate the initial project descriptions based off of the initial sales calls with the client. And so then you probably used to have somebody sit down for like 4 hours and write up all the material about the client, write up all of their project goals, write up what the first assignments are going to be, all of that. But 50% of that's templated information. The rest of it is already in the calls that you had with that client and the back and forth emails. And so the AI can just scoop up all that data and generate all of those initial documents for you. And
I've used like ChatGPT, Perplexity, all this other stuff. You got to really look at it and watch it because it just makes stuff up sometimes that's not true. I've seen in certain fields where I have a lot of knowledge and I ask these large language models about stuff, it just makes stuff up or it's not true. And if let's say you're in the, if the information you're going to give has requirements to be legally factual, what do you do to make sure that your AI is not hallucinating on you or again, just producing garbage?
So there's a lot of prompting techniques and automation techniques like logic loops and secondary checkers that we use to ensure accuracy. And the level of those, the style in which we build those varies depending on how critical the operation is.
So what's a secondary checker? Like, how would that work? What's an example of that?
So let's say you have, first, let's take a step back. How does an AI, how does large language models are what we're talking about, how do they actually work in terms of generating the text in front of you? It is very important to understand why you can hit that regenerate button on all of the apps, because the way they work is they are essentially predicting bunches of tokens. And so tokens are like groups of characters, or words is generally about one token, one word. They are predicting the tokens that are going to come next. So the reason we have those hallucinations is because there is some outlier prediction that gets chosen instead of the most common result.
Okay.
So
what does regenerate do in a large language model? Like I get an answer, I don't like it, I smash the regenerate button. What does it do?
Runs that prediction chain again. So every word, it's then predicting what is the next word. And it's going to run that whole chain again for the response. So you can get a different response because it's going down a different path into sort of that infinite branching setup. Does that make sense? I know we're getting a little heady, I feel like.
No, it's okay. Well, all right. So regenerate button is one method if you get an unsatisfactory answer.
That doesn't work inside an automation. There's what hit a regenerate button.
Well, what if you had as part of the automation? What if you took you averaged together 3 runs of of an LLM using like a regenerate command, or if you did, let's say, 3 different prompts that are very similar, and then combined all the outputs into something, would that generate anything more favorable, or is that's not how it works?
So you're actually very close. You're on the right path. Our most common solution is going to be generating, if we know that hallucinations are a fairly common problem in a data set, we are going to do 5 or 10 generations, and we're not going to average them, but we're going to go with the most common occurrence set. And the reason we don't average them, it's a really simple reason we don't average them. It's likely to cause another hallucination.
Oh, really? Okay.
We're adding another step in the mix. Another one that we use, especially in social content generation, is we will have one model that will call like a writer with its own writing prompt. And then we will have an editor and a fact checker. And those are going to be 2 more separate ones. And so then the writer will get feedback from the editor and the fact checker. And
are the editor and the fact checkers humans or the other LLMs?
They're other LLMs. So for a fact checker, we're generally going to use something like a Gemini because it has near perfect recall.
Okay.
And so that allows us if we know that it is as a very specific example, I have an AI that I use to generate case studies. And it is very common that it will hallucinate on the number of employees and the revenue in the case study because those are numbers. They hallucinate much more often on numbers.
Because it's tuned more for the language instead of numbers.
Yep.